Okay, so looking at some of the big ideas of graphing, we know that graphs, equations, and tables are all interconnected. Okay, if I have a graph, I should be able to come up with an equation or a table. If I have a table, I should be able to draw the graph, come up with an equation. The other part of this is there's two things really that we're looking for when we talk about straight line relationships. Okay, and that's all we're really kind of dealing with right now, is straight line relationships. When we talk about a straight line has a slope or an angle to it, and a straight line has a position. So this line could be down here, it could be up here. Okay, so it has some positioning associated with it. So what is the algebra or the math part, the formal math that connects the angle and slope and the positioning? Where does it show up in the graph, in the equation, in the table? So we kind of know in the graph that we're looking at that slope triangle now. That slope triangle is going to be found in changes in the table on the outside. Changes in y, changes in x. Where does the slope show up in the equation? Okay, this is what we're starting to look for. And what's the other part? The positioning. Remember, we want to talk about the starting position, right? When x is 0. Okay, when x is 0, where's that show up in the equation? Okay, where are these parts showing up in the equation? Okay, so let's take a look at this. So we're going to do some graphing and try to relate these algebraic parts to these physical parts of slope or angle and positioning. And we want to do it in all three forms, as graphs, tables, and equations. So let's take a look at filling out this table of values. So we have an equation. We should be able to come up with a table. I come up with the table by plugging in values. So negative 4 times 3 plus 5 is going to be negative 7. Negative 2 times 3 plus 5 is negative 1. 0 times 3 plus 5 is 5. 1 times 3 plus 5 is 8. So there's my table. I can draw this graph. Okay, I'm going to start at the starting point. It's always good to have that starting point of 0. So at 0 we get y equals 5. Okay, when x is 1, y equals 8. Okay, when x is negative 2, y is negative 1, negative 4, negative 3, 4, 5, 6, 7. Okay, so that is giving us a straight line. That straight line is caused by a constant ratio or a constant rate or a constant slope. Okay, so what is the value of y when x is 0? Well, that's going to be y equals 5. And that shows up right there physically on the graph. And notice that plus 5 seems to be connected to that position. That plus 2 seems to be connected to that position. Okay, so we're just going to maybe highlight that and say that maybe those things go together. So that's one piece of the puzzle. We have the position, we can see it on our graph, table, equation. The other thing is the angle. Well, we want to know the ratio of change in x and change in y. So we want to do the change in y. So we could do any 2 points. I'm just going to use the first and third. You can use any other ones you want. So here I've got a change of plus 12. I've gone up 12. Okay, so from negative 4 to 0, I've gone up 12. Okay, so the change in y equals plus 12. Okay, it's gone like that. My change in x, I need to show it on the outside of the table. Okay, so negative 4 to 0 is plus 4. So it's going to be a plus 4 change. There's my change in x. Okay, so what is the ratio of change of y to x? The change of y to change in x is equal to 12 to 4. Okay, or we can simplify this as our slope ratio. Okay, so we're just going to give it its name. It's slope. So the slope is equal to the change in y, okay, which is plus 12 over the change in x, and that's plus 4, which gives us a slope ratio of 3 to 1. When we divide, we get the slope ratio of 3. As a one number slope, remember that the other number implied is 3. Sorry, the other number implied is 1. So this is two parts I'm looking for. I'm looking for a starting point. I'm looking for an angle or slope, and I can find it here. The starting point can be seen in my table, in my equation, in my table, in my graph. Now the slope ratio, this triangle, it can be shown here. The slope triangle, it can be shown as changes on the outside of the table. Okay, but notice that that 3 also shows up as a multiplier in the equation. And it's not by coincidence. These things are connected. So we can see the two parts that matter, position and angle or slope, in this form, the equation form, in the table form, in the graph form, as that y-intercept and a slope triangle.